Okay, guys, so I think we can start today's session and maybe we can just rewind the things that we have discussed in the last class. Like, we have talked about ROS Move It and how to set up a Move It package for your robot, and we have seen some simulation like how to path plan the robot using move it and send the trajectory to simulation. And I think I have put some references, some examples, and we will come back to move it later, some advanced concepts, and we can see the ROS move it again in ROS 2. So both things are the same. So if you check move it, you can see it is compatible with ROS 1 and ROS 2. Okay, move it 1 is for ROS 1 and move it 2 is for ROS 2. So it is compatible with the latest ROS 2 version, which is ROS 2 Humble. Okay, so the same framework. So learning move it, like if you learn move it, then it will be compatible with both the ROS distribution, not distribution, ROS version, I will say. Okay, so that was the last discussion that we have worked on, like mainly ROS move it. And now today I just want to discuss a separate topic, which is comparatively a, what will I say, small topic, but I will say an important topic if you are planning to work with point cloud or image processing or all these things. Okay, so that is the ROS Nodelets. And the second topic is ROS Gazebo plugin. I don't know, like I can finish these two topics, but let's see. Both are, I mean, small topics only. But the second topic is actually for like creating things in the simulation. Like if you want to create a new sensor, if you want to simulate a new sensor, then you need to write a plugin in Gazebo. Okay, so that is what we are discussing in the second chapter. So I think we can start with the Nodelets. Okay, Nodelets. So maybe I can start discussing by showing some pictures. I think that some graphs. I think that will be good for a start. Let me just check if there is any good pictorial representation. Yeah, I think this will work. Yeah. Okay, thread 1, thread 2. Okay. So I hope everyone are aware of how to write a ROS node, right? Like simply how to write a ROS node and how to publish a topic, how to subscribe a topic. So publishing and subscribing is basically like communication, like it is exchanging data, right? So I'm not sure you are aware of the background process that is involving in this communication. Okay, so maybe I can show you a demo. Like I'm planning to just show you the talker and listener. I mean the Hello World program for the ROS. So I'm simply starting the ROS core and I'm starting ROS CPP tutorial talker, and then ROS 1 ROS CPP tutorial listener. Okay, so in these two examples, one is publishing and one is subscribing, right? So we are running three programs basically. One is the master, one is listener, and one is talker. Okay, so we can just check the system monitor in order to check the process. Okay, process, I think you already know, like if you compile and run build a program, and if you run the executable of it, then that executable turn into a process. So a running instance of a program is called a process, right? So if you just check, you can able to see the process that we are running now, that is ROS master, Okay, ROS master is there, listener is there, and also talker is there. Okay, that you got the idea, right? So there are three uh, three separate process is actually running. Okay, so you can see talker is actually using like 8.9 MB RAM, and also it is using some network as well. I think network usage is not shown here, but there are some bandwidth consumption for this. So all these resources are mentioned here. Okay, in the system monitor. If you check the task manager in Windows, there is a similar tool called system monitor in Ubuntu. So from that we can able to find. Okay, so what is a disadvantage of this communication? What is a disadvantage? Like I think during the discussion of computer vision, like OpenCV, point cloud, I actually mentioned about this issue. Like when you send big chunk of data like image or point cloud, what is happening in background is like, maybe I can show you that with a diagram. Maybe I can take a PowerPoint and I can explain it, so you will get the complete picture. Okay, okay, so let me take a blank. Okay, so I'm taking the example of talker and listener. So here is talker and here is listener. Okay, so talker and listener. So when you start these two nodes, it's basically like communicating with each other, right? It's communicating. But in order to communicate between these, actually these two processes are running in our operating system, right? So what happening is that this talker message is actually serialized. Okay, it will be serialized. Okay, serialized means currently the talker is publishing the hello world, right? So it will be sending in a sequence and we have to serialize it. Okay, because we are communicating using the underlying technology, that is the TCP IP. Okay, specifically called TCP ROS. Okay, that is the communication protocol that we are using for the communication between any nodes. So this message, that is the hello world. Okay, just a second. Hello world have to serialize, and that serialized data is sending to where? To the listener. Okay, the listener is subscribing to it. Okay, so that serialized data is sending, and in the listener side we have to deserialize it. Okay, deserialize. So you know, like we are taking a chunk of data and we have to like serialize it and deserialize it. So who is involving in that process? Who is involving? I mean, the RAM is involving, CPU is involving, because there is some computation we need to do. Like we have to like break down the chunk of data into individual data, and then we have to send it, right? Send through sockets or something. Okay, so these serialized and deserialization will take CPU consumption, and if you are like sending a text data, it is actually fine. I mean, there is no big chunk of data. It's pretty fine. But imagine you are sending like an image or a point cloud which is having a size of like 12 MB. Okay, 12 MB. Just imagine. So 12 MB data is actually serialized, and then the same data is deserialized here. Okay, imagine if two nodes are subscribing to this image. What about three nodes? Okay, so I think you got the point, right? So if multiple nodes are like publishing or subscribing with like with high bandwidth data, then the CPU consumption will I mean there will be some CPU consumption for the serialization and deserialization, and that is actually like, I mean, we can avoid in some situation. For example, if you are running these nodes in the same computer, okay, for example, talker and listener, what we are running is in the same computer. But even if we are running in the same computer, the serialization and deserialization is happening like 3 times. Okay, so we are wasting a lot of CPU and RAM for it, and also there will be some kind of latencies. Okay, latencies actually coming into the picture. So how we can avoid this scenario, especially in case of high bandwidth data like image and point cloud. Okay, so that's where the Nodelet importance is coming. Okay, so here I mentioned that if you are writing nodes like talker, listener, these all things are separate process. Like talker is a process, listener is a process. I mean, these 3 listener are independent, individual process running. Okay, and it is communicating over socket and serialization, and it will take CPU. So there is a new concept called Nodelets. It is actually, I mean, kind of node, but it is working in a different way. Okay, the Nodelet is actually a single process, and the things are running as a thread. Okay, for example, maybe I can show you a situation, so you will get a clarity. Okay, so what I am trying to do is I am trying to do a filtering operation of a filtering operation in an image. Okay, in an image. So I will explain 2 scenarios. I am doing the filtering using ROS nodes, and I am using ROS Nodelets for the same operation. Okay, so first I am showing with ROS nodes. Okay, so there is a ROS camera driver, okay, which is actually sending the image data, right? It is actually sending the image data to a node. Maybe a node is subscribing into it, and it is doing filtering. Okay, and then maybe another node is maybe processing it or something like that. After filtering, it is processing. Okay, processing the filtered image. So the flow is like ROS camera driver will publish the image, the raw image, and filtering node will be subscribed to that raw image, and after filtering node subscribing to it and applying the filter, it will be sending to the processing node, or it will be publishing the filtered image, and processing node will be subscribing to it. Okay, just imagine this kind of scenario, because in ROS we are actually writing modular code. We are not trying to integrate everything into a single node. We are trying to do it in a modular way. So here you can imagine camera driver is publishing and filtering is subscribing. So there is a serialization and deserialization happening once, then filtering and processing again. Here is serialization. Okay, so this is the case of nodes. There are three nodes, 3 processes. Okay, but if you are using Nodelets, okay, if you are using Nodelets, imagine these 3 things are Nodelets, then these 3 nodes are running in a same process. Okay, same process, but in different threads. I hope you heard about the threading technique. Maybe you can same process. Okay, same process running as thread, and the most important point is there is no copy transport. I mean, maybe the correct word is 0 copy transport. Okay, so I will explain that. So the important point here is, if we are using Nodelets, we can run these nodelets in a same process but in different threads, and there is no transportation delay as well as the serialization deserialization happens between this. Okay, so that is the advantage. Like, this is the main point. The point is, if the ROS camera driver is publishing some data to the filtering, basically the underlying technique is it is using a technique called shared pointers. Okay, shared pointers. So the using the shared pointer, we are not actually sending or publishing the data. We are actually sharing the location of the address, like location of the data mainly. Like, the ROS camera driver is publishing an image. Okay, so when it publish and when the filtering node let's subscribe to it, what filtering node get is that the location of the image. It is not getting a copy of the image, but instead of that, it's getting the location of the image. Okay, so there is no sending or receiving involved, only sharing of addresses. So that will save the time of sending. There will not be any latency, and also it will be very efficient because there is no CPU computation involved for serializing and deserializing. Okay, so this is the main application of Nodelets, and we are using Nodelets for this kind of application. For example, if you want to do some processing on some point cloud. Okay, so just think this is a depth camera driver, and which will be giving point cloud, and we will be doing some filtering. Then maybe if we are maybe we have to do segmentation, and we have to do some other things like object detection, for example. Okay, object detection. Okay, so if you want to perform a series of algorithms, okay, series of algorithm in a very efficient way, the Nodelets will help. Okay, Nodelets will help, and the Nodelets are like plugins actually. Okay, so individual Nodelets are like plugins, so that we can actually like load these plugins whenever we require. So for each Nodelets, there will be an input and output. Mainly, like input will be the subscribing topic, but output will be the publishing topic. Okay, so the depth camera will publish the point cloud, then it will be subscribing by the filtering, and the filtering will be publishing. Okay, so it's a series of algorithms. Okay, series of algorithms. So this kind of applications like for images and also for point cloud, we can do these process without any cost in the transportation of data. Like, if these are ROS nodes, then you can just imagine the point cloud data, the bandwidth may be like 20 MB or something. Okay, per second it is sending the 20 MB data, right? So it has to serialize and deserialize in each section, here, 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 and here. Okay, so we can save that, and we can also write modular code. Even if we are running in a same process, we can write a modular code for Nodelets, and these modular code are like plugins. It can be reused, it can be like dynamically loaded, and then it can accept some input and produce some outputs. Okay, so this is the main differences in Nodelets. So you may have some questions. So why don't we use Nodelets all the time? Yes, the Nodelets is having some advantage, but the thing is, one disadvantage that I have seen was the Nodelets may not work with different networks. because it is using the shared object or shared pointer, right? So it will work on the same PC. Okay, same PC. But imagine this scenario. Okay, so this is one PC and I have some nodes here, maybe detection node. Okay, and this is actually in another PC. Okay, so this is on another computer. So maybe I can show you that. Okay, PC1 and PC2. Okay, so if it is a ROS node, then these nodes can communicate with each other. Okay, but like, because ROS node is using the publishing and subscribing, so it will send the data over the network. So if there is any Wi-Fi network, it can send the data. But for the Nodelets, it is mainly targeting for the process running on the same system. But if it is an inter computer communication, I think at that time we need to use maybe node in between. Okay, so that is my understanding regarding the Nodelets. It will mainly work in the same PC, because the technique that we are using in Nodelets is the shared pointer. And in ROS 2, we are considering all the nodes as Nodelets, but they have some other techniques to communicate between different computers. Like if you have two or more computer for a robot, all these computer can run ROS, and all these computer can run ROS nodes, and they can able to communicate. Okay, in ROS 2. So in ROS 2, the situation is
Sorry, I have.
no problem.
Yeah, I have started.
Yeah. Go on.
In ROS 2, basically it is a DDS model, right?
Yes,
So
yes.
the process between the two nodes will be a serialization, what I understand
Yeah,
from the
yeah.
documents.
Actually, the thing is that they actually considering. I mean, in DDS, what happening is that there is shared pointer is also happening. The serialization is there, but DDS is also making use of the shared pointer. So that can actually reduce the effective delay. Like in ROS 1, it is using TCP IP or specifically called TCP ROS, which is heavily using the serialization, but DDS is much better than that. It's actually using the shared pointer as well. Like there is also serialization happening, because if we are using an intra or like if there is a communication between two computers, then this shared pointer will not work. So from my understanding, even if we are using DDS can make use of the shared object, not shared object, shared pointer, which can reduce the latency of the communication. So that is what I have also like got it when I gone through it, Bharat. So I think both methods should be there. In order to communicate between two networks, there should be like sending or receiving, right? The shared pointer will not work. But
Yeah, I mean, in a distributed environment, I think data serialization will more effective,
yes,
and within the same
yeah, within the same shared pointer.
it will be the share pointer
Exactly,
will be
exactly,
more effective.
exactly,
Okay.
exactly. That's how. So, but in ROS 1, by default, that capability is not there. But in ROS 2, if you are working with the same PC, then there is no serialization or deserialization. So that is what my understanding. Like, if there is any change, I can mention it later. Okay, so that is one major advantage that I am seeing with ROS 2. But in ROS 1, we need to specifically work on the Nodelets in order to improve the performance, which is actually the application that is running on the same PC. Okay, so yeah, so this is a abstract idea, like how the Nodelets work, how it is different from the normal nodes. And so you may be thinking like, how difficult is Nodelets or compared to nodes? Like, otherwise, if it is too easy, then we can, start working on Nodelets, because in most of our application, most of our nodes are working on the PC itself, right? So it will be efficient, right? So yes, we can create nodelets for sure, but compared to nodes, it is slightly difficult, okay? Because nodelets actually following a plugin framework, so each nodelets will be acting as independent plugins. So you can load that plugins during runtime. So that is the concept, okay? So we will get into that, the programming aspect and some examples, okay? So let me know if you have any doubts in the concept, like what is the main difference between ROS 1 node and nodelets. If you have any doubts, let me know. Otherwise, maybe I can jump into the the
I have here one
yes,
point.
yes,
When you communicate the with the due to data serialization, you need to somehow need to maintain some kind of protocol.
yes,
So is it ROS will automatically take care
yeah,
of, or
yeah,
it how
yeah.
is it?
So
I mean to say like the first will be the ID, second address, then
yes.
will be data
Yeah,
serialization.
yeah. So that's why I
Yeah.
think I have mentioned that. That is called the TCP ROS. So you can see it here. It
Okay.
is the most common protocol
Okay.
in is TCP ROS. So mainly using the
Yeah.
TCP IP socket. So just
Yeah, because the bandwidth will be fitted for TCP only. Otherwise, CAN and other things will be less bandwidth. It is 8 bits only, so it will be not feasible.
yeah,
That
yeah,
I feel.
yeah, yeah, yeah. True. So this is the top level protocol that ROS is actually using, TCP ROS. And yeah, in ROS 2 we are using the DDS data distribution service, which is the main difference between ROS 1 and ROS 2. So yeah, so this is the thing, and you can see how the nodelets work. It's mainly using the shared pointer, and this is one algorithm, this is another algorithm, and it is running on different threads. And there is another another process called nodelet manager, which is actually responsible for loading each nodelets. Okay, so there will be another program which is actually responsible for loading these nodelets. Okay, so it's very easy to work on, but the programming part, it's slightly difficult. But if you are keep on working on nodelets for some projects, I think you can crack it. So that is what they're saying, like any communication between them can use the zero copy ROS-CPP publish call with a boost share pointer. Okay, so if you publish and subscribe using Nodelets, there is zero copy. Okay, zero copy transport. Okay, so that is what. So that is the main point. Maybe I can just share this link, because this is one diagram that we can use for comparing normal nodes and nodelets. Okay. Yes. So if you just search for the Nautilus, you will get the wiki page, and you will get an idea as well. And I mentioned, right, it is like a plugin. So each Nautilus is acting like a plugin, and there is a framework called plugin lib. I will explain that. And yeah, so all the things that I mentioned, I think they have uh, listed here. Okay, and the main application is like high throughput data flow can be composed in many nodelets and loaded into same process. So that's what I mentioned about the point cloud. Like if you have a high bandwidth data, if you want to process it, then you can able to do it in a modular way using nodelet without sacrificing the performance. Okay. Yes. And there are some existing nodelets available, for example, for OpenCV. So if you just search for OpenCV nodelets, just a second. OpenCV, just Nodelets example and PCL Nodelets. Yes, OpenCV also there are a lot of example, but let me, yeah, okay. This is not the thing, stereo processing. Maybe I can start with the PCL. Yeah, you can see here the PCL is having a set of nodelets. Like it's kind of plugins, and you can reuse these nodelets as well. I'm actually showing some examples of existing nodelets, guys. So maybe if you just go to I think these all are yeah, you can see here ROS nodelets. So just read this title. PCL ROS includes several PCL filters packaged as ROS nodelets. Okay, and the links are actually given here. So what happening is that imagine you are working on a point cloud application. Okay, and you may have to do some filtering and you have to do some segmentation. So if you want to do the filtering, you don't need to develop your own nodelet for do the filtering. There are some existing nodelets available which can be reused. For example, extract indices, pass through filters, then radius outlier. It's all like voxel grid. This is one famous filter, like it is downsampling the point cloud. So all these things are available. So all these nodelet will have set of input and set of output and also some parameters. Okay, so if you can map these input and output and configure these parameters, then the nodelet will work, something like that. Okay, so this is very handy because we don't need to write any code. We just need to load this plugin. That's it. Okay, so yeah, so that is the main advantage. And if you are only using nodelets, we don't need to write lot of code actually. Like we can reuse a set of nodelets that is available already. You can simply pass this point cloud data through a series of nodelets and we will finally get the output, something like that. Okay, and there are OpenCV examples which is having nodelets. OpenCV tutorial ROS. There is a big set of tutorial, sample code using nodelets, but I need to just find it. I think it was there actually. Let me check. That tutorial was actually very good because I'm not sure you have seen the OpenCV library and its set of examples. They have a lot of examples of Python and C++ example. So this repository that I am trying to get is having almost all the examples which is in converter into nodelets. Okay, like this you can see here. So if you want to do some image processing, we can simply use that nodelets. Okay, I don't know where it is, mostly in the ROS perception. I don't know whether they removed it or not. In the Vision OpenCV, let me check. Okay, got it. It's in the OpenCV apps. Okay, so this is the repository that I'm talking about, guys. It's a very interesting repository, and I think some of the packages are already installed, but I will prefer you to clone this repository on your Catkin workspace, and you can able to see a set of nodelets here. Okay, so all this codes are nodelets. Okay, you can see here a simple example for nodelet in OpenCV. So a load of nodelets, I will say. Okay, so yes,
Can you please walk through one sample, one which how the
yeah. So
knowledge
the
is, so that others will understand?
yeah.
Yeah.
So regarding the code walkthrough that I'm going next, I mean going to explain next. So I was just I mean mentioning some examples, but we have a simple Notlet. Okay, so we will see the walkthrough of that first. Okay, so this is actually OpenCV based. So like even if I explain it, there are some OpenCV elements. So which is like if you are not understanding, that will be a problem. So there is a very simple hello world example with us. So I will explain that. Okay. So this is one good reference. Okay. And also with the PCL, if you just go to the ROS perception group, and if you just go down, I think you can also find the PCL perception PCL. Let me check. Okay, maybe in the perception PCL. Yeah, see here, the nodelets actually present. So a list of nodelets actually here. So these all are representing nodelets actually. Okay, so in order to work with a PCL application, you can simply use the existing one. Like if you want to do a segmentation, a nodelet is available, so no need to write any code, just load the nodelets. Okay, so these are some examples I mentioned. Okay, so I think you got an idea, right? Like what is node and nodelets and the examples. And now we are going to a very basic example, so you will get the clarity how to write a nodelet. Okay, yes. So just going to the first example. It's in nodelet hello world. Okay. Okay, so I will explain from the package level. Okay, just a second. Okay, so in order to start creating a nodelet, first you have to create a package using the catkin create package. So you can just name it like nodelet hello world or something, and inside that you can find these files like the package.xml and cmake list. So make sure the dependency for the nodelet is available. Okay, so that is the important part. Like in order to create a new nodelet, you have to include the nodelet package. Okay, both in the build dependency and also in the run dependency. Okay, so build dependency is actually the dependency which is helpful for building the package, and the run dependency is what we require for running the nodes actually. Okay, there are some runtime dependency and also there are some build time dependency. Okay, so nodelet you have to include in both like build dependency and run dependency. Okay, or you can simply mention as depend. Okay, so this is the main add-on for the nodelet package. Okay, and there is another things called export, so that I will come back after some time. So this is the main change or main thing that you have to do while creating a nodelet based package. Okay, so it's simply like if you want to create a package, you can use like this. Just go to the workspace and to the src folder and use the catkin create package. Then you can include raw cpp because the nodelet is only available in cpp. Okay, so I will discuss another point here. So in order to add the nodelets, just mention nodelets. So that's it. Okay, so some of the students, I mean some of the student that is yeah, I mean who are already enrolled or like who are planning to enroll, they ask me like which programming language that you are using for your course. So I mentioned that I'm using C++. So what happening is that most of the ROS courses that is available, I mean most of the courses, even from Construct and I mean they are focusing on Python. That is what I have seen. There are C++ courses, but mostly they are focusing on Python. So what happening is that these kind of high level stuff like Nodelets, plugins, then controllers, writing path planners, all these things are generally written in C++. Okay, there is no way of writing planners in Python, okay, using a ROS API. So that's why we are preferring CPP for this course, okay. And also in order to work with high level stuff like point cloud and images, that will work with Python, but the performance will be much better in CPP, okay. So Nodelets will only work with C++. Just want to point out that. Okay, after creating the package, you can start writing it. Okay, so in the package.xml, you have seen this, and regarding the export, I will explain later. And in the CMake list, there is nothing complicated. Yeah, there is a small difference. I will mention that. I will mention. But yeah, maybe after explaining the code I can explain. Okay. Yes, add library, nodelet hello world. Okay. Yeah, so I will explain that. Fine. Okay, so just go to the hello world code of the nodelets. Okay, how a nodelet will look like. So that is what we are going to see, and after that we can go with some more examples. I think I have a calculator. Oh yeah, maybe I can discuss later. Okay, so just check how a nodelet will look like. I mean the structure. Okay, that is what I am talking about, and that is also mentioned in the ROS wiki. So if you just go to the nodelet page, you can able to see the API, like how a nodelet should look like. Okay, so in the programming side, if you want to implement a nodelet, the fundamental thing that you require is the nodelet class. Okay, so if you include the nodelet package on your package as a dependency, then what we are getting is the nodelet class. Okay, so nodelet class is called we can call it as a base class. Okay, the nodelet class is having some virtual function or some functions in which we can inherit this nodelet class into our nodelet. Okay, so if you want to create a nodelet, you have to inherit from the base class, which is nodelet. Okay, and this is actually the namespace. Okay, I hope you heard about the namespace, right? So nodelet is the namespace, and inside this namespace there is a class called nodelet. Okay, so this is an important step, or this is a first step you have to understand before starting writing a nodelet. Okay, start writing a nodelet. So inheriting. Okay, so this is actually the inheritance basically. Okay, and also you have to understand what is a namespace is, how to write a namespace. So I mentioned that nodelet is actually like a plugin. Okay, like a plugin, and each plugin is loading in a thread. Okay, there is only one process. Okay, one process, and that process into that process we are loading multiple plugins. Okay, so these multiple plugins are available in different namespaces. Okay, so the differentiating factor between these plugins is the namespace. Okay, so for example, this namespace called Nodelet Hello World is having a nodelet called hello. Okay, so the namespace is what is the differentiating factor. Okay, so here we can write a set of nodelets inside the namespace, and if you want to add another namespace, we can create. So namespace is basically a differentiating factor. Okay, I just mentioned. So under this namespace, we can write several nodelets. Okay, and this is a basic syntax, like how to start with a nodelet, and inside this class we have to define a set of functions. Okay, set of functions, and yeah, so that's it. So the important function that we have to define is the onInit function. Okay, onInit function. So I hope you heard about the virtual functions in C++. Virtual functions are like these functions we can override this function. Basically, like this class is called base class, right? And we can inherit the functions from this base class into the derived class, which is the hello. Okay, so inside the derived class we have to write some functions. Okay, some functions called like these functions. No, the onInit is actually available in the base class, and we have to write the definition in the derived class. Derived class is hello. Okay, so all these functions are written like virtual functions. So we have to, like, we can override the onInit. Okay, like the nodelet class is having some initialization, but we can initialize our own nodelet using this mandatory function called onInit. Okay, so this should be this will be like a mandatory function that you have to include, like virtual void onInit. Okay, and inside that you can do the initialization of nodelet. Initialization means like in a nodelet we need a node handle similar to the ROS nodes, and you can also define the publisher, subscriber, all these things. So this nodelet is simply a publisher and subscriber nodelet. Okay, so what happening is that there is a topic called message in, which is actually subscribing by this nodelet. Okay, so when the nodelet subscribe to message in, it will call a function called callback. Okay, it's actually triggering a callback, and inside this callback what happening is that we are publishing the input that we have received, and we are just publishing the same input that we have received. Okay, so the structure is like, maybe I can show you. So we have a nodelet called hello. Okay, just a second. Okay, so this is the hello nodelet. Okay, hello nodelet. Okay, and so the input of this nodelet, or the nodelet, is subscribing to what topic? Message in. Okay, message in is the topic that is subscribing. Okay, and what is the topic that is publishing by the nodelet? It is message out. Okay, message out. And okay, so as I mentioned, the nodelet will have set of inputs. Input means the topics that it is subscribing, and output means the topics that is publishing. Okay, and there will be some configuration. So this is what happening in our sample nodelet, and the message out inside the nodelet, the processing is message out is equal to message in. Okay, so this is what happening. Not int, Okay, so this is our hello world nodel, and when you check the code, you can see it is subscribing to message in, and whenever there is a callback, the callback is triggered. The callback is very similar to the callback that we have seen in the ROS node, and inside this we are publishing it. Publishing, it's a string data, right? So this is the received input, and we are just feeding that received input to a ROS message called output, and we are publishing the output. Okay, so maybe I can show you the demo of it, and then we can discuss. Okay, then we can come back to the same program. Okay, so let me just go to the launch file. Just a second. Okay. Okay. So maybe I can show you a demo, and then I will explain the code again and the launch file. Okay. So let me load the Nodelet. Okay. So ROS launch, then Nodelet hello world, then hello world.launch. Okay. So what happening in this launch file is that we are starting the same Nodelets in two instances. Okay, so we have a Nodelet called hello, right? Nodelet hello world / hello. Okay, Nodelet hello world is the namespace, and hello is the name of the Nodelet, right? And we are starting the two instance of the same Nodelet. Okay, same Nodelet. So effectively, we can see like we are actually giving, in this example, we are giving the first Nodelet name as test1, and second Nodelet names as test2. Okay, so if you just list the topics, you can see test1 / message in, test1 / message out, and test2 / message in, and test2 / message out. Okay, it's showing two Nodelets loaded with the name of the Nodelet. Okay, name, or like here you can see you can actually name the Nodelet, like the nodes. Okay, that you can actually give a name to this. Okay, like the nodes. So ROS, I mean test1 and test2 is the Nodelet name, and you can see here. Okay, and now we can simply test this Nodelet. Okay. So what I'm trying to do is I'm echoing test1 message out. Okay, so is there any output now? No, right? Because there is no input. Okay, if we publish some data into test1 / message in, then that will be published in message out. Okay, that is the intention. So what I'm trying to do is I'm just publishing some data to test1 / message in. Okay, and it's a string type. Okay, so I'm just hey, I'm I am test1. Okay, some messages. Okay, and I'm publishing at a rate of 1. Okay, 1 second. So I'm publishing it, and you can see here the message out is actually publishing the same. Okay, so now you can see the test1 Nodelet is working. Okay, so what about test2? So that is what we are seeing next. Okay, so again the same procedure. We are like echoing test2 / message out, and then we are publishing test2 / message in, then standard messages, string hey, I am test2 with a rate of 1. So you can hear from test2 out, hey, I am test2, and both are actually working. Okay, both are working at the same time. And if you check the ROS node list, you can see these two nodelets as two nodes actually. Okay, literally we can see, we can see as two nodes, but it's actually like in a single process. Okay, it's in a single process, and there is no serialization and deserialization. Okay, so I didn't test the bandwidth, just let me test it. Bandwidth, maybe it's showing the bandwidth of that topic, because this let me check. Yeah, okay, so this will show some bandwidth. Okay, ROS, just a second. Okay, we can just leave that. Okay, so you can see here the two nodelets are running, and you can use the RQT for viewing the process. Just closing the plugin. Nodes, where is the nodes? Node graph. Okay, so you can see here. Yes, so we have a standalone nodelet manager. Is basically the nodelet manager, which is loading two nodelets, which are the nodelets test 1 and test 2. And in test 1 we are publishing a topic, and it's outputting the test1.message out, and the same thing for the test 2. Okay, so this is a concept, like individual nodelets. We only have one nodelet, but we have ran two instances of it. Okay, so I'm just stopping the demo and coming back to the code. Okay, I think you got an understanding about the flow of this code, right? So this is like a plugin, and there is no main program here. I think there is no, yeah, this is like a library or like a plugin, and the header file that we have to use is the nodelet.h. And also I mentioned, right, this is like a this is actually using a plugin infrastructure in ROS called plugin lib. Okay, so which is using in ROS 2 as well, plugin lib. So this is the library that we are using in order to create plugins in ROS. Okay, this is a very interesting library, because using this library there are multiple concepts like nodelet, then controllers, path planners, and all kind of libraries, all kind of plugins are using the plugin lib. Okay, yes. So regarding the code, we have to include the main header file, which is the nodelet.h. Then we have to inherit from the base class, and we have to define the onInit function. Okay, so if you just check for the nodelet class, I think the nodelet class is available here. Nodelet, yeah. So you can able to see the nodelet class functions onInit. Just a second. Yeah, this is the class that we are talking about. Yeah. Okay, so nodelet, and we actually defined onInit. Let me check onInit function. Yeah, here onInit function we have defined. So like that, there are many functions that we can use. Okay, so in order to just get started, I think this structure will help you. And inside the Nodelet, if you want to print something, you can use ROS info. I mean, instead of using ROS info, we have the Nodelet debug. Okay, so we have to create a node handle. That is what happening here. So this is not creating a new node handle, but it's actually getting the node handle of the process that is loading these plugins. Okay, so it is actually getting the node handle, and using the node handle we are creating the publisher and subscriber, and it's actually a class, right? So the publisher and subscriber is actually mentioned as the data members here. So ROS publisher pub and ROS subscriber sub, and it is initializing here. Okay, and whenever there is a callback, it will call this function. Okay, this is a user defined callback, and it will be publishing it. So this is the situation. Okay, and yeah, so next is how to compile it, how to build it. So that is a little bit complicated, but I can explain that. So Nodelets are basically like libraries. Okay, you heard about the C++ library, or simply a class like a .cpp and .h file, which is having a class. Okay, so similar to that, in CMake list we can build a Nodelet using this. Okay, rest of the stuff is almost the same as the normal ROS node. So only thing you have to check is that this is how we can compile a C++ library. So if you want to build an executable, you are using add executable, right? Add executable. But instead of add executable, we have add library. Okay, for Nodelets we have add library, and which source code that we are using? Hello world.cpp, which is this. Okay, and this is how we are creating the library. Like in target link library, the library name that we are giving is Nodelet hello world. Okay, that is the outcome or the output of the build. Okay, when you build it, you will get the library called Nodelet hello world. Okay, and yeah, so you can install it if you want, otherwise you can simply build and you can able to use. But the important stuff is here, like after building this library, okay, what you have to do is there is a tag called export. Okay, export, that's where the things are getting complicated somewhat. So I'm sure that you may not be using this tag in package.xml, okay, called export. So by default this export tag will be available, but I don't know you know the usage of export. Okay, so simply the export tags are using for like for a visibility. Okay, visibility. So what is the visibility? For example, you have created a package. Okay, you created a package called Nodelet hello world. Okay, and inside this package there are a set of Nodelets. Okay, and your package is actually placing in a workspace. Obviously the package will be placed in a workspace, right? But there is a difference between your package, I mean this Nodelet hello world package, and other packages, because this is actually having libraries instead of nodes. Okay, just executables. Okay, so the Nodelets or the plugins or whatever we are going to write, like it can be a plugin, it can be a controller, it can be some kind of, I mean any plugins, all these plugins are kind of library, and all these plugins has to export in the package.xml. Then only the ROS tools can find these libraries. Okay, because all these plugins have to load dynamically. Plugins are like that, right? If you have a software, you can load that plugin and you will get that feature. Okay, so in order to find these plugins dynamically, you have to add this export tag. You have to include the export tag, because inside this export tag we have to mention an XML file. Okay, this XML file is having the information about the Nodelet, like information like the name of the Nodelet, the base class of the Nodelet, and the path of the Nodelet, something like that. So when the Catkin Make or any other tool go through these packages, it can specifically address these export tags to find the list of Nodelets and plugins. Okay, if this export tag is not available in the package.xml, then the Nodelet will not be visible. We can't able to load the Nodelet. Okay, so this is very important. Like the export tag is very important. The export tag, the usage is like, for Nodelets you have to mention like Nodelet plugin, and you have to use a prefix, meaning like this means prefix is a package name, package / the hello world.xml. Okay, you can name the XML file as any name. So just check what is inside the hello world XML. Okay, so
I have a small doubt here. How do we know that what are the dependencies required for this Nodelet?
Okay. So so I think I have mentioned that. Just a second. Yeah. So for the Nodelet now, for compiling it, the basic dependency is the Nodelet itself, the Nodelet package, because the Nodelet package is having a base class. Okay, that is just a second. I think we have seen the wiki ROS page, right? So yeah, so this is the wiki page for Nodelet. Maybe I can share the. So this package is having the Nodelet base class. Okay, so what we are doing is we have to include this package in our package.xml. Then only we can able to inherit from this package, I mean from the class. So the basic dependency is the Nodelet only, and if you are using some different ROS messages like sensor messages or geometrical messages, then you have to mention that. So that is same for the nodes. Like you can put anything on this code, like you can subscribe to an image, you can process it. So depending on your requirement, you can add the dependency on the package.xml. Okay, so if you are manually adding this dependency in package.xml, make sure you are updating on the CMake list as well. Okay, like the packages that we are seeing here, right? Nodelet CPP standard messages, that is also seeing here. Okay, so both should have the same dependency. Okay, so mostly like when you create a package, you may be editing the package.xml and CMake list. Okay, so make sure if you add a dependency here, you are changing here itself. Okay, so Bharat, I think for your question, it will depends, but the mandatory dependency is the Nodelet. Okay.
So in general, this is fine, but in the case some kind of point club or some other things, I don't know the examples. So I'm just to how we can recognize. Now I got it.
So for the point cloud, so if you check, maybe I can quickly. So in order to work with the point cloud, we have like you can just search for ROS point cloud, and you will get to know like we need a ROS message called sensor messages. I mean, this is a main package which is having the definition of point cloud. So the definition that we are using for point cloud is point cloud 2. Okay, point cloud 1 is the primitive message, we are using point cloud 2, and also for the image there is the data type, I mean the ROS message is here. So basically if you need to work with the OpenCV images and point cloud, just include the sensor messages, that's it. Okay, sensor messages, okay, both in build and yeah, so that's how we are adding.
Yeah.
Okay. Okay, so coming back to the discussion, like we have been talking about the XML file. So I mentioned that the XML file is having all the information about the Nodelet. Okay, so this is the kind of a template for a Nodelet. Okay, so so we can see like we have defined all the aspect of Nodelet here. Okay, so first we can see library path libnodelet hello world. Okay, so when you check the CMake, you have seen the name of the library that we have created is Nodelet hello world, right? Nodelet underscore hello underscore world. So you can see you can prepend or you can append lib, then the name of the Nodelet. Okay, name of the library that we have seen in this CMake list. Okay, so that is the first one we have to mention. So they got the name of the library. Okay, then in a tag called class, you have to mention about the Nodelet class and type and also the base class. Okay, so the name, I think name is you can use the same name, I think. Okay, you can use the same name, that is Nodelet hello world / hello, and the type is I mean Nodelet hello world is the namespace and this is the class name, and the base class is of course the Nodelets. Okay, so that is what we have seen here. This is a base class and this is a namespace, this is a class name. Okay, and so I think that's it. Almost all the information we have filled, and if you want to fill up with some description, you can do that, and that's it. Okay, we have done with the XML file. So we have mentioned the library file, then class type. Type means the like namespace ; class name. Okay, and we can give a name just following this convention, and the base class is Nodelet. That's it. Okay, and so that's it in the XML file. And so we have seen how to include the export, then we have seen how to build the Nodelet. Now we are coming to the launch file. So how to start a launch file, how to start a Nodelet. So I mentioned that in order to start a Nodelet, we need a Nodelet manager. It's a standalone actually a program that is coming along with the Nodelet package. It's called the Nodelet manager. Okay, so this is actually same for the controllers, ROS controllers and ROS. Yeah, in almost all the stuff there is a manager. So first thing we have to do is we have to start this node called Nodelet manager. Okay, so you can use the same line, like from the package called Nodelet, you have to start Nodelet and with an argument called manager. Okay, so after this we can start the Nodelet. Okay, so this is the convention to start a Nodelet. First you have to mention the package as Nodelet, then you can mention the type as Nodelet. These all are the same. The difference is that you can give a name, okay, test1 or any name you can give, and in the argument I mentioned that Nodelet is a plugin. Okay, so in order to load this plugin, you have to mention the name of the Nodelet. So this is a name. I think you have seen this name before, right? So this is the name of the Nodelet. So that we have to mention. Okay, so after mentioning it, you have to like mention like standalone Nodelet. All these are same. Okay, so only difference will be this. Okay, here we are using the same Nodelet, but the name is different. Okay, so this is how we can start a Nodelet. So we can start any instance, any number of instance of Nodelet. So this is here you can see 2 instances, and this is the template that you can use for starting a Nodelet. Okay. Okay, so when you start the Nodelet using the launch file, you can see here it's actually initializing with 4 worker thread and loading Nodelet test 2, test 1, all this. And you can also see the list of topic it is publishing, and you have seen the demo, right? For example, if you publish the test message in, if you echo it, you will get the test message out, similar to the test 2 message in and test 2 message out. Okay. Okay, guys, I think so. This is the first topic that we have. We are planning to, like, we already planned to discuss. So maybe in the next class, maybe I can talk about the vision algorithms. If I can show some application, okay, using OpenCV, and then we will be discussing the Gazebo plugins. Okay. So yes, I think we can conclude for today's session. So it's a time for questions. So let me know if you have any question, guys, regarding the Nodelets. Let me know if you have any questions. You can go through this Nodelet page, but initially when you go through it, you may have some confusion, but I think this session may help you to understand some of the concepts. Any question, guys? Okay, so if you don't have any questions, we can conclude today's session, and tomorrow there will not be any class. I am planning to do it on Sunday, so I will be announcing the class date. Okay, tomorrow there will not be, but on Sunday we can do. So thanks for attending, guys. See you on Sunday. Bye. If you have any doubts, let me know. Okay, bye everyone. Good night.